Just like with any function, I can find the domain and the range of an absolute value function. There are some formulas that you can memorize, which I'll give you at the end of this notes page, but I don't love the formulas. The formulas are just going to be in your short-term memory, and you're going to forget them really quickly. Also, even if they're in your short-term memory, you're likely to get them confused on an assessment. Therefore, I want you to try this other strategy and then just use the formulas to check your answer. Okay, here's the strategy. Look at the function rule, identify the transformations, use the transformations to sketch the graph, and then from the graph, find the domain and the range. Let's do that. First example, f of x equals the absolute value of x minus 5. Now, one single transformation is happening here. I'm shifting the graph down 5. I'm shifting the graph down 5, and so I can sketch my graph that's just shifted down 5. Unless it says that you do not have to label the vertex for a sketch, but I'm just going to label it because I think it's helpful to understand how we are identifying the domain and the range. Okay, so I shifted my parent function down 5. That means my origin went from 0, 0 to 0, negative 5. Again, it's not required to label the vertex. It's just helpful if you'd like to do that. Okay, now let's use that sketch. What is the domain? Well, this graph goes forever to the left, forever to the left, forever to negative infinity, and forever to the right, forever to positive infinity. That means the domain is all real numbers, which I'm going to write as bold R. What is the range? Well, the vertex is really important for the range. The vertex is my lower point on my graph, and so the y-coordinate of that vertex represents my lower bound for my range. The smallest possible y-coordinate is negative 5, and then for every y-coordinate bigger than negative 5, there is at least 1 point, 2 points on the graph. My range then, when I have a lower bound of negative 5, is y is greater than or equal to negative 5. Where I got that negative 5 from the fact that my graph shifted down 5, moving my vertex down 5. Next example. F of x equals 3 times the absolute value of x plus 2. What are the transformations here? Well, first I have this 3. The 3 is a vertical stretch, which is my fancy way of saying my graph is steeper. And then the plus 2 inside the absolute value bars moves my graph left 2. So the opposite of what I think inside the absolute value bars, I think right, it moves it left. Here is my sketch. A steeper vertically stretched graph that's moved left 2. What's my vertex? My vertex moved from the origin left 2. My vertex is negative 2, 0. Okay, what's the domain? Well, my graph, even though it's steeper, it still goes forever to the left, forever to the right. My domain remains all real numbers. What's my range? Well, I still have my vertex acting as my minimum point, my lowest possible point. So the y-coordinate of that vertex gives me my lower bound for my range. There's 1 point on the graph with a y-coordinate of 0. There's no points on the graph for smaller y-coordinates. And then for every value greater than 0, there are 2 points on the graph. My range then is y is greater than or equal to 0, that y-coordinate of my vertex. Let's keep going. Next example. F of x equals negative 1/2 absolute value of x plus 2. 3 transformations here. We have a negative, which represents a reflection, reflect over the x-axis. We have a 1/2, that is a vertical compress. My graph is flatter. And then the plus 2 outside of the absolute value bars means I'm moving up 2. Okay, so reflect over x-axis means my v-face is down. Vertical compress means it's flatter and I'm shifting up 2. So something like that. What's my vertex? I didn't move left or right, so my x-coordinate 0. I moved up 2. So my vertex is 0, 2. Okay, the domain, even though the graph looks really different, my domain remains all real numbers. The graph goes forever to the left and forever to the right. What's the range? The range is different. Whereas when my v faced up, my vertex represented my lowest possible point, my lower bound. Now my vertex represents my upper bound, my maximum point. The value of 2 is still important, but now rather than the minimum y value, this is now my maximum y value. There's one point on the graph with a y coordinate of 2, and there aren't any points on the graph for bigger y values. However, for every y less than 2, there are 2 points on the graph. My range is y is less than or equal to 2. Last example. F of x equals -2, absolute value of x minus 4 minus 1. The negative sign, again, is a reflection. A reflection over the x-axis. The 2 is a vertical stretch. I have a steeper graph. Inside the absolute value bars, I'm moving left or right, opposite of what I think since I'm subtracting h. So minus 4 is not left, it is right 4. And then outside the absolute value bars, I have that minus 1, so that is down 1. Okay, I need to draw a steep reflected graph that is right 4 and down 1. Steep, reflected, right 4, down 1. What's the vertex of that guy? Well, I moved right 4, down 1. That's going to be 4 and -1. Just like in my previous example, since my graph faces down, my vertex is my maximum point, my upper bound. That means the y-coordinate of my vertex represents the maximum possible y, my upper bound. Domain remains all real numbers. Range is y is less than or equal to -1. All right, let's establish some formulas. First of all, you can memorize, it's okay, the domain is all real numbers for all of these graphs. Every absolute value function has a domain of all real numbers. If the graph goes up or if it faces down, the arrows still point forever to the left and to the right. That probably won't stay in your brain forever though. So just know if you forget what the domain is, sketch out an absolute value function graph and identify that the domain is all real numbers. What about the range? What's important here? Let's look at this number. -5, -5. Ooh, invisible 0, invisible 0. 2, 2, -1, -1. It's my k value that determines what my part of my range. The other part of my range is determined by a. So if a is positive, I'm going to have a greater than or equal to. If a is negative, I have a less than or equal to. If a is positive, my graph, my v faces up. My vertex is my minimum point, and so it represents a lower bound, and I have a greater than or equal to symbol. If a is negative, my v faces down. My vertex is an upper bound, and I'm going to have a less than or equal to symbol. In either case, k is the parameter that's important. H does not affect the domain. H does not affect the range. A and k are what's important for the range. A determines the direction of the symbol, greater than or equal to or less than or equal to. And then k gives me what that lower or upper bound is. If you can memorize this, great, but you should also be able to sketch the transformations to check your answer.